This is the fourth and final lecture of topic 3, which is all about naming and formula writing. This is actually going to be new for most of you. This is organic formula writing and naming, and College Board doesn't require a lot of it, but you should be comfortable with pieces of it so that it's easier for you to know what's going on. So I'm going to actually walk you through a fair amount of this, but I do want you, as usual, to have your learning targets set up in your notebook first. So if you haven't done this yet, you'll want to use the 2 links to make sure that you have what you need in your learning target notebook, but definitely set up the foundation first. Okay, so when you're ready, then you've made your own notes, go on and watch and add as you watch. I'm going to do several examples with you. All right, so hydrocarbons are compounds made of carbon and hydrogen. Clearly, they may also have oxygen or sulfur or nitrogen, but everything that we are going to deal with right now, and they may be rings, they may be branches, etc., but everything that we're going to deal with right now is going to be what we call straight chain hydrocarbon organic naming. So the idea would be that you're going to make a chain of a bunch of carbons all linked together, and then depending on the name, you'll add in double bonds or triple bonds, and then you're going to add enough hydrogen so that every carbon has 4 bonds. And then, once you've done that, then you can write the chemical formula from that. That would be if you're given the name. If you're naming them, then you need to go the other direction. So this uses the Greek prefixes mostly to talk about the number of carbon atoms in the chain. And if you have a branch chain, it would be in the longest chain, but everything we're going to do right now is just straight chains. And then the suffix tells you what type of bond is between carbon atoms. So if the ending is ane, like octane, then they would be all single bonds. If it's ene, then it's going to be at least 1 double bond. If it's more than 1, they'll say diene or triene, so that you know how many double bonds. And if it's YNE, then it's a triple bond, at least 1. And again, they'll number it unless you know where to put it. So the number would be after that number carbon. And you can start from either end of the chain. So we'll talk about how to do this just a little bit. You should know that then every hydrogen, or the hydrogens get added so that every carbon has 4 bonds. And then you should know that these are normally your Greek prefixes, but the first 4 are for organic use. And so they change. It's not mono, di, tri, tetra, it's meth, eth, prop, bute. Okay? And then it goes back to the regular prefixes. So let's do some examples so that you can see how this works. If I give you the name pentane, you're going to use pent to say 5 carbons and ane to tell you single bonds. So I'm going to start by drawing this with 5 carbons. And since they're all single bonds, then I need to add enough hydrogens to the carbons to make each carbon have 4 bonds or have its octet. All right, once I'm done with that, then I can also do this, by the way. If you've had organic chemistry or you've seen it before, sometimes they don't actually draw the hydrogens, the H's for the hydrogens, they just put on spines like that, okay? So this would be pentane, and I'm going to count. I have 5 carbon and 2, 4, 6, 8, 10, 12 hydrogen. And so this would be the formula for pentane. All right, go ahead and write these other examples in your notes and sketch the models so that you are ready to talk about it with me, and then we'll do them together. Okay, so 2-butene. Butene, bute is 4 carbons, and ene tells you a double bond. All right, so I'm going to draw 4 carbons. And then the 2 tells me that after the second carbon is the double bond. In this case, it doesn't matter which end you count from, but I really have 2 options. It could be here or it could be here. And if I started from the other end, this is the same as putting it here. Okay, so I need to tell you where it is, and this 2 tells you after the second carbon, so the double bond goes there. All right, so I'm going to put in the double bond. And then I'm going to add enough hydrogen, 1, 2, 3. This one only needs 1. This one only needs 1 because of the double bond, and then 1, 2, 3. So now this is going to be C4H1, 1, 2, 3, 4, 5, 6, 7, 8. And this would be 2-butene. Okay, if you needed to know where that was, you could also write it as CH3, CH, CH, CH3, and this would tell you where the double bond was, because you would be able to tell where the single hydrogens were, that there must be a double bond in there. Okay, so just kind of be aware that this is different ways that we could notate this. Okay, 3-octine. Oct is 8, so I'm going to put 8 carbon, 1, 2, 3, 4, 5, 6, 7, 8. And octine tells me a triple bond, and the 3 means after the third carbon. So 1, 2, 3, it's going to go here. I'm going to put in my hydrogens. These two on the either end of the triple bond don't need another one. And everybody else, until we get to the other end, needs 2. So this would be C8H. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All right. Or I could write it as CH3, CH2, C, C, CH2, 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 CH3. Or I could even do this, CH3, CH2, CC, parentheses, CH2, 1, 2, 3 of them, CH3. So all of these are different ways that those could be represented. All right, I need to clear up some space here. Let's go backwards. All right, so let's do some naming from this. I see 3 carbons in a chain. If I need to draw it to figure out what the bond structure is, I can do that. This one has 3. This one has 2, this one has 3. They're all single bonds. So 3 meth-eth-prop but. So prop tells me 3 carbons. A-N-E tells me all single bonds. This one, CH2CH2. So I'm going to draw this to show you that I have CH2CH2. And these carbons don't have 4 bonds, but I can't put more hydrogens because they told me how many, which means that there has to be a double bond. In this case, there's only one option for where to put the double bond. It's pretty obvious, so we're not going to put a number on it, but we are going to say 2 carbons. That's eth, meth-eth-prop-but. That's eth, and then double bond E-N-E. Okay? All right, let's try from model kits and see what happens here. Let me clear this space off a little bit. And I want to show you how you're going to have to count what's going on. So you may have to write as you go. I see CH3, CH2, 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 CH3. So since all of these in the middle are CH2, I know that everything's a single bond. So I can literally go 1, 2, 3, 4, 5, 6, 7, 8. This is 8 carbon. And I can count all those hydrogens if I want, but because they're all single bonds, I know now that this is octane. Okay? And that would help me with that. Let's look at this one. This is a little harder. This is CH3. And this is CH. So I'm actually going to write this because the other ones don't have hydrogens on them. So it's CH3, C, C, H. Okay? So these 2 carbons must have a triple bond in between them. All right? And now technically, I'm going to start at the lowest numbering system, which would be from this end. And so I don't have to tell you where the triple bond is. This would be ethine. Okay, I know that you wanted to do like 2 ethine, but it's really after the first one, and it doesn't really matter because I can flip it over and get the exact same thing. All right, let's look at this last option. Why don't you stop the video and try it yourself and then restart the video. Okay, let's see what you got. There's CH2, CH, CH3. So I get CH2, CH, CH3. This is 3 carbons, so this is going to be prop something. And then if I draw it, it's CH2, CH, CH3. So this must be a double bond, okay? And that's what I can see there. And so as I'm doing this, this is going to be ENE. And I just realized I made a mistake on the one up above it, so we'll go back to that, okay? Sorry, this is 3 carbons, so this is propene. Propene, okay? And again, because I can roll that over and it doesn't matter where I put it, it would look the same. We don't need the number. Let's go back, because I just realized I probably confused you. This one is not eth anything. There are 3 carbons, so this is propyne. Okay, sorry for that error. I'm glad I caught it right now. Okay, so let's come back down here. There's only one other thing that's in this set of learning targets, and that would be your common names of like water and ammonia. Ammonia really is an organic name, but it's not something that you know yet. So those you should definitely make sure you know, and then don't forget your diatomics. This would be elements that when they are elemental, they have to be 2 atoms together. There's a few others that I put on the list that you should memorize, but these diatomics we use all the time. So you definitely need to make sure that you are aware of this. If they're in a compound, they don't have to be diatomic, but you definitely need to know that if they are as elements, they should be. This is review, so hopefully you already know this. There's a couple different ways to remember it. Brinkelhoff is BRINCLHOF. That gives you all 7 of them right there. Or you can say know-how, like so. Or I do 7, 7, 7. So I start with number 7, make the shape of a 7, and the 7th one is hydrogen. Okay, but these are definitely things that you need to memorize. All right. So there's your organic naming and your miscellaneous stuff, and this concludes topic 3. Now we're ready to use it in topic 4.